Hello. Today's topic is street collision. Collision in Chinese means 撞击,相撞. Okay, so first one, elastic collision. Second one, inelastic collision. Third one, perfectly 完美的, perfectly inelastic collision. So the definition, this means the changes in kinetic energy before and after is equal to 0. Or you can say Ke is conserved. It's a constant. So this one here means delta Ke, it's not equal to 0. So Ke not conserved. This one means inelastic plus that the two mass after the collision, they stick together. They stuck together. 粘在一起了 after collision. 撞击之后 after collision. Okay? So inelastic, so this is true, plus that they stuck together, the two M1 and M2 after they, right? So they were here, moving that way, for example, and they were there, moving this way. Once they hit each other, they stuck together, okay? All right, so that's the three collision. And let's give one example. So example one. So let's say if you have, let me changing color here. So you have M1 equal to 1 kilogram, and V1 equal to 1 meter per second. And then you have M2, slightly bigger, M2 equal to 2 kilogram. But your V2 is equal to 0.5 meter per second, for example. Okay, so this guy is going this way, and this is V2, all right? Now let's say after collision, V1 is going to the left. V1 prime, okay, it's going to the left, and that's equal to, say, 0.5 meter per second, going to the left. And now we want to find what's V2 prime it's equal to, okay? All right, so let's do it. So we use conservation of momentum, right? So don't use it in AP tests, but just in your, in this lecture with me, conservation of momentum, linear momentum. So that says M1 V1 plus M2 V2 is equal to M1 V1 prime plus M2 V2 prime, okay? So we are saying that the friction is zero, right? Mu is equal to 0. So this one tell you that the external force, net force, is equal to 0. So you can apply COM, okay? So this is true. So then you can say this one is true. This one is true. All right, so let's do it. So 1 times 1 plus M2 is 2. And then V2 is going to the left. So that's minus 0.5. Minus. It's equal to M1, which is 1. And then V1 is going to the left. So minus 0.5. And then plus M2 is 2 times V2 prime. Okay? So this one, 2, this is actually equal to 0. You see that? Okay, so then 2V2 prime will be equal to, is equal to 0.5, right? So you move that to the other side. So then V2 prime is equal to 0.25. So you know this guy, after collision, is going to go this way with 0.25 meter per second. all right? And let's see if this collision is elastic or inelastic, okay? So let's check that. Let me changing color here, getting a little messy here, all right? So before KE, before, right? Which is equal to 1/2 m1 v1 squared plus 1/2 m2 v2 squared, right? And KE after is equal to 1/2 m1 v1 prime square plus 1/2 m2 v2 prime square. Okay, so we're checking whether this is elastic. So how much is this? This is equal to 1/2 times 1 times 1 plus 1/2 square times 2. v2 is 0.5, so 0.25 after the square. So then this is equal to 1/2 plus 0.25. So that's equal to 0.75, right? 0.75 joule, right? Joule, right? And what's after? That's 1/2 m1. What's m1 here? M1 is 1. v1 prime is 0.5, so it's 0.25, right? But square, so this is negative sign, but square after the negative sign is still positive. So plus 1/2 m2 is 2, and then v2 prime is going to the right, 0.25. So this is going to be 1/4 square, right? So this one is going to be 1/16. So then this is going to be a quarter divided by 2, so 1/8 plus this cancel out plus 1/16. So it's going to be a, right? So it's going to be 16, right? 16/3, right? So 3/16. So this is clearly less than 3/4, which is 0.75 joule, right? So you can see this is inelastic collision, okay? Because they did not stuck together. So it's an inelastic collision in this case, all right? So we lose some kinetic energy, but our momentum is still conserved, okay? See you in the next lecture. Now, hopefully you learn something in collision.